And I would like to conclude this journey with a personalized medicine project, which is still ongoing for pediatrics, which is called MD Pedigree in the center of this slide, where similarly to the others, we've deployed in 7 European hospitals an architecture allowing the anonymization of the data and its sharing across the different centers in order to validate models in 4 different pathologies: neuromuscular diseases, cardiomyopathies, cardiovascular disease in obese children, and juvenile idiopathic arthritis. But in doing so, we've been facing major problems, because the reality of information systems throughout hospitals in Europe is not that good. We've been facing quite some differences in the different hospitals we have been equipping, from hospitals not having a patient information system and dealing with Excel-based databases, to hospitals overly equipped with proprietary systems. So we've been struggling with interoperability issues, with the problem of structuring the data sufficiently so that it can be shared between the different groups. And beyond that, in the medical area, you have such a richness of data. It's very heterogeneous. So we had to deal with different standards, different protocols, and understands the actual nature of the data. And last but not least, even though this is still an area that is not so constrained right now, we have been facing the issue of making sensitive data available cross-enterprise and across borders. And that is, so we've gone through this journey developing solutions and coming to the point of an architecture allowing to keep the data locally to the hospitals and make it such that it can be shared with a sufficient trust that we will not be able to re-identify the patient. And that is a development that was, for us, very important in the studies we've gone through. But that is now taking much more sense. As you may know, the new General Data Protection Regulation that is coming up within the European Union, that is going to even more frame the way you can collect, store, and process sensitive data. This is a not so simple representation, but at least it gives the main principles. In the very centers, you have the corpus of applicable texts and standards. In particular, you have the, I don't know if there is a beamer. No, I don't think there is a beamer. In particular, you have 2 directives at the European level that are applicable today, that are suggesting 8 major things. So you have to abide to the law. This is lawfulness. You have to bring sufficient security in your system. You have to obtain an informed consent from the patient before you collect the data. You have to bind yourself to the purpose of your study, so you don't process the data for anything else. You have to make sure that data is accurate, that the process is transparent, and that you're accountable. These are the 8 major principles that you have to abide to nowadays. With the GDPR, we are bringing even more important concepts, and you can, if you read it accurately, you can witness 3 major concepts. Privacy by design. You have to take privacy aboard from the design of your system until its development, exploitation, and maintenance. Privacy by design, privacy by default. And the more important one, informational self-determination. So you have to give back some rights to the individuals concerned from whom you get the data, so that they can access, they can modify, they can erase, or they can even ask to be forgotten from your information system. And this is a tsunami in terms of regulations. This is coming up in 1 year from now. It's going to be applied as a supranational law by default by all of the European member states. This is quite a big thing. It's 25 changes, and most of our information systems today are not ready for that. So what we've been working on in the biomedical research actually is answering to part of the problems that the new rules that the GDPR is introducing. It's providing the means to pseudonymize your data such that you have a sufficient basic level for ensuring non-re-identification of your patients. It's providing sovereignty on the data, because the data does not move out from the hospital, but it was not solving the actual problem of accountability and transparency. So we've come up about a year ago with a model in mind, having developed such networks throughout Europe where hospitals are data providers. We've come up with the idea that we could establish a network that shares information about the transactions, about who is accessing what data, under what conditions, and for what purpose. So we've come up with an idea that we've submitted to the European Commission that has now received funding since last November, which is called My Health, My Data, and which is basically a network taking advantage of the so-called blockchain technology to document every single transaction between the centers of sensitive data. So you may not be fully aware about the blockchain and what it is. You may actually confuse it with Bitcoin, so I'm going to just very quickly clarify. So the blockchain is a technological protocol. It's actually made of two tricks. One is cryptographic, so every single transaction in a blockchain is cryptographically signed between the emitter and the receiver. So we use their identities to sign the transaction. So if I was to give 10 euros to you for buying a service, I would sign the note, you would sign the note, and the note would carry our signatures for all lifelong. Next day, you take the 10 euros, you buy something else, you will do the same. You will sign the note, and the other person will sign the note. And this way, you have a chain of blocks, a chain of signatures, and that makes the system really robust, because if you want to falsify one transaction, that means you have to break every single signature until the transaction you want to modify. That is the first trick. The second trick is that it decentralizes the validation process, the decisional process. So you have a number of nodes in a network that are running this blockchain, and they participate to a democratic validation of a transaction. If in that network, they are encouraged to be competitive. So the first validating the transaction and coming back is the one being paid for the transaction. And if you have a certain number of these transactions confirming the validation, then we consider the transaction to be valid. So that helps doing two things. It helps removing a trusted third party. So if you were a bank, so Bitcoin, for instance, is an alternative money that does not require a bank. It's got a network of computers. The decentralization process allows for transactions to be dealt with by the network, so you do no longer need the banks. Here we are not aiming at removing anyone. Here what we are aiming at is making the process transparent. So we want the hospitals, the research centers, the companies, and actually in the longer term, the individuals, to be part of the network. So we want to have these centers collecting the data as proper blockchain nodes, contributing to the validation process and having their data referenced in a catalog that is made available at first for the researchers, and in the longer run in a proper market with valuation. So we've come up with this consortium. It's actually 15 partners. We have 4 and not 3 hospitals involved in Germany, in the UK, in Italy, that will receive the solution, that are actually already contributing data for the sake of research, and that will experiment the use and the setup of this data market for science. Scince is also participating with a number of SMEs and research centers. So behind this, the idea is to use the blockchain as a transparent ledger that will make it that will be available between the partners, between the nodes of the network, and that will register every single transaction taking place. So to do so, we are using the blockchain. We are using specific interfaces to obtain dynamic consent from the people involved, so from the actual patients, and smart contracts. Smart contracts in the blockchain is a blockchain speech. Again, I will clarify. A smart contract is an application. It's like a stored database application. So it's an application that is in the blockchain that can run and modify the content of the blockchain. And in a blockchain network such as this one, only a smart contract can be executed to modify or to add a new transaction in the blockchain. What does that mean? It makes a system very secure and robust. Only applications validated and available from within the blockchain can run and modify the blockchain. No external third-party applications could do so. What we are looking at, what we are looking to do with smart contracts here is to develop a number of these that reflect the conditions under which you can mobilize as a given cohort of data that you would like to access. And last but not least, encryption technologies, as I mentioned, for anonymization and making the data basically secure before it gets referenced into the network. So the idea is to equip the individuals, the patient, with an information system that will guarantee his or her sovereignty and make the whole thing around the person. So we are developing right now new contracts for mobilizing data for pre-competitive research, for industrial research, for commercial contracts. So at first we will have research groups, projects, individual researchers looking to collect data from our system, and for which we will have specific conditions, basically access for free, in guaranteeing the consent of the patients. For other types of accesses, we are now working on a particular business model that I will reflect on after this slide. And last but not least, we'll have GDPR contracts that will be made available to the individuals so that they make their rights applied whenever they want. So GDPR contracts for accessing, for getting a portable version of their data in a personal data account, but also GDPR contracts for being forgotten, for instance. Our longer term is to develop what we call the lowest code. Nowadays, people in the blockchain area talk about the code is low, which means that the blockchain basically makes the law. We believe the contrary. We have to make this work of translating legal contracts into smart contracts, and this is exactly where my company is looking to play a particular role. So this is the model overall that we are working on. As much as today the information system of our society is money, tomorrow the information system will be data, and we want to introduce two valuation of data, not only economic but also societal. We want to make it possible to measure the value of sharing data, both in terms of economics. So what does that mean for a hospital to enter this network? How much will they get back if their data is referenced and made available to researchers? But also, what is the societal impact? Can I benchmark the hospital? What can I do with this data? So we are developing this system that is turning accesses to cohorts into contracts, and then dealing with the different stakeholders to get their consents, do the transaction, and then incentivize the sharing. And then once the data has been secured and made available, we apply a second level of anonymization. So there we use statistical processes before sharing. So this is what we are working on with Almerys. Almerys is a large French group dealing with healthcare insurances, trusted for payments. And we have data about 22 million people. So we are looking to use these technologies to secure the way data are transacted between various stakeholders, including insurances. And therefore, we are working on a new generation of information systems that guarantee by design privacy and informational self-determination. I will not get into the details of that, but we are combining three major types of technologies: big data, deep learning, and blockchain into one single new type of information system. And this is what we have very recently patented as a new invention called general data protection method, that actually is a mix of these technologies to guarantee the security of the underlying information system. So just to conclude, this is for us the new generation type of information system we want to develop to open access to research data for an ecosystem of partners, and at the same time make it possible to accelerate their innovations into a market thanks to this technology. Thank you very much for your attention.